अपना 11:30 का टाइम दिया था ना। जस्ट वी विल वेट फॉर 8-9 मिनट्स।
नो इश्यू, नो इश्यू, नो इश्यू।
ओके।
वो तो आज हमको वैसे छुट्टी रहती है।
अच्छा, सैटरडे।
हाँ, फर्स्ट एंड थर्ड सैटरडे।
ओके ओके।
तो घर से ही देने वाला था, लेकिन घर पे थोड़ा आज बारडोली में थोड़ा इलेक्ट्रिसिटी कट है, तो कॉलेज आ गया मैं।
ओके ओके, चलेगा।
Good morning, participants.
Good morning, sir.
Shall we start, sir?
Yes, yes.
Yes.
So, good morning and very warm welcome to everyone. On behalf of SNJB Sriman Suresh Dadaji in College of Pharmacy, I extend my heartfelt greetings to all the delegates, resource person, faculty members, research scholars, and dear students who have joined us today for day 2 of our 5-day online faculty and student development program titled Innovative Approaches and Emerging Trends in Pharmacology Teaching, Research, and Practice. As the outset, I sincerely thank all the participants for the enthusiastic presence. Once again, the response and active participation we witnessed on day 1 truly motivate us to move forward with even greater academic zeal today. Today marks the day 2 of this program, focusing on the theme research methodology in pharmacology, strengthening research skills in the current era of evidence-based science. Sound research methodology and appropriate data analysis are crucial for academicians, researchers, and students. With this objective, today's technical session has been thoughtfully planned. Before we proceed further, I want to tell one thing. Today, on the birth anniversary of Kranti Jyoti Savitribai Phule, we pay our heartfelt tribute to the first female teacher of India, a true pioneer of women's education and social reform. Her relentless fight against caste and gender discrimination laid the foundation for an inclusive and empowered society. And in her honor, our university has also given name Savitribai Phule Pune University. So a great tribute to the great personality. With great pleasure, I welcome our resource person, Dr. Bhavin Vyas, Professor and Head Department of Pharmacology and Pharmacy Practice, Maliba College of Pharmacy, Uka Tarsadia University, Parduli, delivering the technical session on data analysis and biostatistics for pharmacology research using GraphPad and R. Now, I would like to invite Mr. Rakesh Khandare to kindly introduce today's esteemed resource person. Rakesh sir, over to you.
Thank you. It is my privilege to introduce our today's distinguished speaker, Dr. Bhavin Vyas. Dr. Vyas is currently serving as an head of the Department of Pharmacology and Pharmacy Practice at Maliba College of Pharmacy, Uka Tarsadia University, Bardoli, where he has been contributing to academics, research, and institutional development for nearly 2 decades. He holds a PhD in pharmacy and M.Pharmacy in pharmacology, along with specialization, postgraduate qualification in applied statistics and clinical research. His strong interdisciplinary background uniquely positions him at the interface of pharmacology and biostatistics. Dr. Vyas brings with him over 20 years of teaching, research, and consultancy experience. His research expertise spans preclinical and clinical pharmacology, pharmacokinetic, drug development, and therapeutic compound screening in areas such as CNS, cardiovascular diseases, oncology, and various metabolic disorders. Dr. Vyas has an impressive research output, having published more than 75 research papers in national and international journals. He also successfully managed funded research project around 70 lakhs, reflecting his strong research capability, planning as well as execution. In addition to his research accomplishment, Dr. Vyas is deeply committed to academics mentorship. He has guided several MPharm, PharmD, and PhD students. He also serves as consultant biotechnician, statistician to reputed healthcare and research organization. Dr. Vyas is actively participated in various and contributed in various several national international conference as a speaker, session chair, as well as reviewer, and continues to play an important role in advancing pharmaceutical education and research. Today, we are honored to have Dr. Vyas with us to share his valuable insights on data analysis and biostatistics for pharmacological research. I kindly request you all to join me in giving a warm welcome to Dr. Bhavin Vyas.
Thank you very much for your kind and a little bit exhaustive introduction. First of all, I'm very much thankful to uh, Upasani sir, as well as Aman sir, as well as Manoj sir for giving me opportunity, and also to person who has introduced me. Thank you very much. I'll. He has given a long introduction. I'll try that. I'll be matching that introduction and giving you fruitful information about the topic that is given to me. I like to share my slides. Is it visible?
Yes, sir.
Okay. So.
Make it on presentation mode, sir.
Yeah. I'll make it that. Before I make it that, if I can shut down my camera, it is fine.
Yeah, no
Oh,
problem.
okay. So if there is a issue in the analysis, or I can say internet issue, won't be there. Okay.
Yes.
Now it is on full screen, I think.
Yes, sir.
Yes, sir. Yes.
Okay. Thank you. So s- the topic that is, I can say, is selected by me or given to me is data analysis and bar statistic for pharmacology research. So it is very much important that we should have something called as data analysis and biostatistics. So starting with this, I have few questions that is I have noted, not few, one question that is you can observe on your screen, that is which of this will be killing your drug if you are in drug development research project. So it might be toxicity, toxic impurity that will be there in either in batch 1, batch 2, or batch 3. Or I can say you have a very competitive companies. So you have rivals which has a new molecule and killing your drug. Or as we know, if we want to market our drug into either in Indian market or European or US, the regulators are there. So regulators are individual, and because of that, it will be killing your drug. Oh, important thing, a misplaced decimal point in your p-value. This is also very critical. This is also very critical, that the numbers what you are writing or what you are submitting to either to regulatory authority or you are writing in research article, that will be having very much impact. So today we'll be talking about, I can say, numbers. Numbers. We are talking about invisible, so-called force field that will be protecting your life work related to research, and I'll try to uh, implement that. Because of that numbers, you will be able to differentiate between drugs that saves millions of dollars and rupees, and drugs that dies in phase 3 and eating up your millions and billions of rupees and 8 to 10 years of investment. So that's why it is very much important to know something about, well, I can say, numbers. This is one hypothetical example, and then later on, I'll have some real example where bar statistics play important role. So I'll give that introduction, and then I'll shift to software. Well, I'll be demonstrating you how you can utilize that to software. Okay, so this is one hypothetical example, that is two universe, one data set, or not two universe, I can say two researcher or two company with the same database. So I have given a database that is a hypothetical data set comparing to a new antihypertensive drug versus a placebo in control of systolic blood pressure. So this is, you have the change in blood pressure because of placebo and because of drug that is given in this slide. And if you observe the calculation, placebo, the mean change, I can say it is 19.3, SD is 1.6, and drug is 26.7. So if you observe very minutely, in case of drug column, you have something called as one, I can say, last third is 45, change is 45. And rest, if you observe, it is odd man out. It is odd man out. So if you calculate without outlier, drug mean will be 14 point, I can say, 7, and with outlier, that is 26.7. Now, based on that, because it is of placebo and drug, you have two group. So generally, we talk about something called as independent t-test. So you calculate t value, and from that, at the end, what in previous slide I have told you about the p value. P value. So that is t-test without outlier is p 0.052, and with outlier it is 0.05, and without outlier it is 0.001. So it is a number game. It is number game. But we are researcher. We need to have a look at raw data, what is there in raw data, and according to that we need to interpret, or we need to supply a data, because we are dealing with biological system. Here, when I give antihypertensive drug to patients, or I can say a population, where each and every person is individual, it's hereditary, it's genetic, its ethnic background will be, we can randomize, and we can narrate down, or we can narrow down that biasness still with proper randomization. If still we are conducting this type of trial, this type of situation will be there. So because of that, what will happen is, you will be, because our standard say our p value should be less than 0.05. So if with outlier, if we are calculating, then we say that our drug is failure. And without outlier, we say it is having significant effect, having significant effect. So I can say this is reality. While we are mastering being a pharmacologist in receptor kinetic or pharmacokinetic pharmacodynamic model, there exists something, a parallel battlefield or parallel, I can say, branch, which we called as branch of evidence or battlefield of evidence. That is nothing but biostatistics. That is nothing but biostatistics, where that biostatistic, if you consider that as a battlefield, it acts as your armor, your weapon, and your map. So you need to have biostatistics properly implemented in your research data. Then it will be good, or you can save money, or you can save lives also. This is one real example where I have titled slide why it is important to select a proper taste. I'm audible, no issue.
Yes, sir. Yes.
Okay, fine. So this is a second and real scenario. Real scenario. I think everybody might be knowing the Coxib story, where Merck arthritis drug, Rofecoxib, they have launched. And during launching, they have given a data. So they have selected two group, arthritic with placebo and with your tasted drug Rofecoxib, and t-test applied, and so that there is no cardiovascular risk with that. No risk with that. But after its launch, it launched in 2004, Merck need to withdraw that because of the numbers that is I have given, 14000 heart attack. That is because what exactly happens during that trial? During that trial, they only analyze, or they use t-test. They have not analyzed time to event analysis. It is not that at particular point of time it will be there, your effect is there or not. So same study, just I changed the data analysis from t-test to Cox regression or time to event analysis. It reveals that 34,000% increase in heart attack, and the t-test say there is no risk. So this is real scenario. Just if you change the way of looking at your data in perspective of biostatistics, it makes sense. It makes sense, and it will be causing. So what was the disaster in that, or lesson learned, that is using wrong taste? There is a failure. Uh, much I can say this Merck has lost too much of, I can say, market share because of this Rofecoxib. There is a politics behind that also, that I won't talk at this point. But the point I am saying that you should select, or there is a another branch when you are doing research. There is another
हो
branch,
त्यांच्याकडे असलेली पूर्णपणे वेगळी ती
another branch called as biostatistic. You need to pay attention to that. You need to pay attention to p values or selecting proper taste. Then you can represent that into either in to regulator or to research article to have a good impact. Similar to that, this another case is that is painkiller paradox will be there, where you are evaluating pain scale. So when you are evaluating pain scale, you are collecting a different type of data. And if you apply to same type of statistical test, it will be blunder. It will be blunder. I'll be talking that in later also, painkiller paradox, where reduction, if you do IRT test, it will be different. If you do with some another test called as Wilcoxon, it will be different. So from that, you can have an idea that why proper selection is important. This is third, that is ICU sepsis misdiagnosis. This is real data that is there. So today will ensure that your research makes never headline for wrong reasons. So I'll try to explain what is bar statistics, what is data analysis, what are the few important points you need to take care when you are collecting data, or if you have collected data, what parameter you need to taken care by yourself, so that it doesn't have a headline that because of this is researcher has published or their article is retracted. I have few cases where the research article are retracted because of they have done wrong bar statistical analysis and represented in different form, and that's why their paper were retracted. So I'll try. So from this point of onwards, I'll be explaining what is bar statistics, what are the different nomenclature they are using in that. Then I'll say how to select proper bar statistical taste for your data, for your data. Then this will be taking, I can say, half an hour to 45 minutes in explanation of what is bar statistic and how to, what are different type of data and what type of test you need to select. Then I'll be shifting to, I can say, software I'm going to demonstrate to you. One is called as R Studio and second is known as Jamovi. I'm not touching about a Prism because it is a paid and licensed version. So I'm not going to talk about. I'm talking about freeware and well accepted by FDA also, that type of software. So R is I'm talking R Studio, more precisely R Studio, and another is Jamovi, where one is I can say based on the program you need to write a language, and second is menu driven, which is user friendly. Okay, so that's why. So starting with theoretical portion. So it is bar statistics. It is nothing but branch of statistics where uh, collection, analysis, interpretation, and presentation and organization of data will be there. It is considered as a grammar of science. Grammar of science, it is called as grammar of science. So when I talk about biostatistic or when I talk about any research or when you do any experiment, you should come across with this type of, I can say, terminology called as variables. Variables are nothing but characteristic that you observe or you manipulate. Depending on that, it is called as dependent or independent variable. Either you observe or you manipulate, depending on that. Data is nothing but measurement or observation of that variable, either dependent or independent. And parameter, it is any number, numerical quantity that characterize a given population or some aspect of it. Either you measure a blood pressure, or you measure blood glucose, or you measure height. So measurement of that is one parameter, one parameter. So I can represent that in a form of central tendency called as either in form of mean, either in form of median, or what is the range, or what is the standard deviation, or what is the variance. I can represent that. That is called as parameter. So generally in bar statistics, the parameter, when I say parameter, I'm talking about whole population. But when I talk about statistics, so we are not doing anything on whole population. We collect some sample. So if I want to know what is the blood pressure of Maliba Pharmacy College staff blood pressure, or Ukadarsada University staff blood pressure. So my university has odd 550 of teaching staff. So it is not necessary that I go and measure everybody's uh, blood pressure. So what I'll be doing, randomly selecting. I have randomly around about 20 institute. So from 20 institute, I'll be taking few samples. So when you are doing bar statistic, you are always carrying out any analysis or any interpretation from to sample, and the result from sample what you are getting, then you are inferring that or extrapolating that to population, because at the end we want that my drug is working on population or not. So whole population I cannot work. So this is a common terminology that is used in bar statistic. When I use population mean, it is noted by mu sign, and when I say sample mean, it is noted by x bar. So there is something called as parameter, and there is something called as statistics or sample and population. Sample and population. This is very basic thing. So what scenario I have told you that selecting a wrong taste leads to headlines. So selecting appropriate taste depends on this parameter, this four parameter called as type of data, what is your research comparison, and what is your study design, and last, because we are dealing with bar statistics is a part of mathematics, and when I do any mathematics, everything any manipulation I'm doing is based on some assumption. So this assumption should be matched. It is like assumption, but if it is not matched, whole analysis will be in vain. Okay, so as such we say what is assumption, we need not to check assumption. Its data type is this, we should go for this. No, unless and until you have checked assumption, then and then you can apply for particular type of statistical analysis. So these are the four parameter where appropriate selection of taste will be depends type of data, research question, study design. I'll go through very quickly to this how it is important, then I'll show the how it is selected. So first is type of data. I think you might have learned in I can say also in schooling also, during B Farm, M Farm, as well as if PhD students are there, then during coursework they might have learned about this data types. So generally two type of data are there: discrete type and continuous type. Discrete I can divide into two type called as whole number, where number of student, number of books. I cannot have half a student or half book like that. Or some statistics can say there are two kind of data called as categorical data and continuous data. Categorical data, and where categorical data I can have two type, nominal and ordinal data, and in continuous I have interval and ratio data. So this is important. What you are collecting, what you are collecting. So one pain paradox, what I have told you, where I am collecting outcome, that when I am giving a drug molecule, the pain is relieved or not. Or if I am giving any molecule, because of that any pain is induced, which is mild, moderate, or severe in that so when I'm collecting my outcome in that manner, I need to select proper test. I cannot apply anything on that. Or if if I'm collecting my outcome in continuous or ratio manner, like any outcome with a unit, either in milligram per deciliter or mm of Hg, or in centimeter on centimeter square, like that, generally they are considered as a continuous or interval data. And there are some nominal data. When we do some clinical research, we come across with this type of data also, when we publish something called as descriptive analysis of our data, where either male and female, ethnic background, or socioeconomical status. So there are nominal data where I cannot have any order, and ordinal data where I can have order. So statistical taste depends on data type. So these are a few other examples of nominal, ordinal, inter, and uh, so first two are considered as a categorical data. Last two are considered as a continuous data. Many authors or many books will be publishing like that. There are only two type of data: categorical data and continuous data. Okay. Other important thing in selecting is type of data analysis. What type of data analysis you are going to apply on your data that will be giving. So this four type of, generally anything you take, either department pharmaceutics department, pharmacology department, pharmacognosy chemistry department, or clinical research, they will be either selecting of this or combination of this, called as descriptive analysis. That say you are just explaining your data. That is, what is the mean of your data, what is mean height of your population. That is nothing but descriptive analysis, which is important when you have two groups. So the both the groups should be randomly, there is no biasness. So descriptive analysis of two groups, if you present, and the mean age of both the group will be having no statistical difference, that say I have my respondents or my two grouping are random and there is no variation in that, so I'm controlling that. That's why this descriptive analysis is also important. People ignore that, but when any paper comes to me, first I look at the descriptive analysis. Any article with me, or any student give me the data, first I'll tell them to have a descriptive analysis table. I look at that, and from that I can have an idea, is there any biasness or randomization is followed or not. We can look at from that only, or the trend of that population I can check in that descriptive analysis. Second most important analysis generally researcher will do is known as inferential statistics. Inferential statistics, that is, what are the characteristic of population when we are comparing two groups or two or more groups, placebo with taste drug, or standard of care with a taste drug, like that. If we are comparing, or model control with taste, or normal control with model control, so that is nothing but inferential statistics, where you are comparing two or more group. Associative, that is change in one group, a change in one parameter will be changing in another parameter. Uh, Correlation, regression type of thing, that is nothing but associative type of analysis. Associative type of analysis. Generally, this associative type and predictive type are very famous. I can say people in. I'm not having any biasness to particular department. Still, I'm saying the pharmaceutics people, when they are doing formulation, now they are applying something called as design of experiment. So where they are doing data analysis are nothing but based on associative and predictive analysis. Associative and predictive analysis, where if I change the concentration of disintegration, what will be the effect on hardness of that particular tablet, or friability of that particular tablet? What is the association between that? So in that I try to correlate between two variables, and having I can say regression analysis. Predictive analysis will be also that, where I'll be typically formulating one equation. So in future, if I am changing small change in one concentration of one drug, one excipient, what will be the effect on its outcome, either in dissolution or in hardness or friability, like that. This can be also applied to pharmacology also, that if I give a different concentration of dose, what is the change in blood glucose level, or if I'm having a predictive type. If I am having a one ethnic background, to that I am giving particular drug. If I'm changing and now I'm giving to another ethnic background, so what, how it will be behaving, forecasting that, forecasting probability. So it is applied to each and every branch, but to make you understand, I'm giving easy examples. So generally data analysis will be, you will be doing this only. Beyond this, it will be very much difficult to do. Okay, so either you will be doing descriptive analysis, inferential and statistics, or inferential analysis, associative analysis, or predictive analysis. So, so I have told you that it depends on four parameter: type of data, research question. Now, third is study design. Study design. It refers to a structure plan, how your data is collected, organized. So where you have one group, two group, three group, four group, a dependent variable, independent variable. So it depends on whether your subject are independent, different group, or paired in same subject. First, you have measured the memory score. After you have given some, I can say, taste or some drugs, and after 6 months or 3 months, what is the improvement in memory? That you are checking. That is known as paired one. In same subject, you are measuring same outcome multiple times. So that will be paired. Okay. So this also depends on study. I can say study design. Dependent and independent variable, it is a very common thing still. To, I can say, briefly going faster, independent variable is experimental, that is changing, that is independent variable we generally call as x, and dependent variable is variable being tested and measured in experiment, and it depends on independent variable, we generally noted by y. So important thing is what you are measuring, y is what type of data type. Either it is continuous type of data type, or it is categorical type of data type. And on that basis, you will be selecting particular test. Okay. Other is assumption. Assumption. So generally we say our data is normally distributed. That is it follows something called as this bell-shaped curve. Other distribution are also there, like Bernoulli or Poisson or exponential or gamma distribution, beta distribution. So depending on the distribution, your tests are available for that. But what we do in our analysis, so we generally consider this normal distribution, and all other are non-normal distribution. Non-normal distribution. So we have category of taste are there. So if your data is following normal distribution, you have set of tests that you follow. If it is following non-normal distribution, you have set of tests, you will be following that. Okay. So I'll be skipping that the detail of distribution I have given, but it is not important for you. That's why I'm skipping that. So, but for assumption, when you do analysis for assumption, you need to have this type of thing called as checking normality. Checking normality. So checking normality is nothing but your dependent variable. You just plot a graph, histogram, and from that you can say it is normally distributed or it is not normal. If it is following bell-shaped curve, it will be having normal distributed. If it is not, then there will be a skewness or kurtosis will be there. And there is a fundamental thing: as you increase number of sample, normal distribution will be followed. If you have taken 6 sample, the chances are there that the data will is not normal distributed. But if you increase the samples, there is a chances that your data will be. Now you have the formal statistical test are also there for normal distribution. That is, I'll demonstrate. When I demonstrate, I'll explain this. So I'll be skipping this. So coming to selection. So if researchers simply answer the question what is there in your screen, it will be giving you answer what type of statistical test you should select. So it is almost, I can say, 30 minutes odd. I have finished. So I'm finishing somewhat faster and then go to our software or our studio. So if you answer this, how many independent variable are there? What is the level of measurement? Level of measurement means of independent means categorical or continuous data, that either of dependent and independent variable, how many our observation are dependent or independent, is there a correlation, or independent, or same population you have measured or not. Same thing I have present in previous slides, but this is another way of presenting and a simple form of questioning and answering. Simple questioning and answering. So if you answer that, that will be giving you idea. So this is one flow diagram I am giving you, so it will be easy to select particular test. For example, you are conducting, being a pharmacologist, you are giving a drug and measuring that it is effective in controlling blood glucose level or not. So blood glucose level you will be measuring in milligram per deciliter or in other units. So generally it is considered as a continuous data. It is considered, not generally, because its characteristic is that's why you call that as a continuous type of data. So when you have this type of dependent variable, what is the independent variable in this condition is that I have two groups. In one I have given a placebo, in second group I have given taste drug. So what outcome I am measuring is blood glucose level. So what blood glucose level, I consider that as data type is a continuous data type. Second important parameter is I need to check for assumption. That is the data what I have collected, it is normally distributed or not normally. So you apply for normal distribution, taste of normality. And there is a two possibility. If it is following normal distribution, then you will be selecting something called as parametric test. I'll come to that, what are the parametric, what different type of parametric test. At this point, if it is following normal distribution, you should have a parametric test. If your distribution is not normal, then what first step you need to take? Just try to transform that data. So you take log of that blood glucose level, or you take inverse of that, you transform that. Then on that transform data, again you apply something called as taste of normality, and check if it is following normal distribution or not. If it is following normal distribution, you go for parametric test. And if it is not following, then you can go for not non-parametric test. Why I am focusing on parametric test? Because when I do parametric test is always done based on the assumption. If it is following first criteria, second criteria, third criteria, fourth criteria, and the predictability of parametric test is highest as compared to non-parametric test. That's why we try that on our data, we should apply something called as parametric test rather than non-parametric test. That's why when our distribution is not normal, we try to convert our data into another form. And then we'll apply. If it is not following, not non-parametric test will be there. If it is following normal distribution, now comes the third. So type of data, assumption. Now third is your this one. I'm talking about what first, third. I'm talking about this type of data, assumption, and now I'm talking about this two. Depending on that, research question and study design. Research question and study design. Okay. So after completing this, at the end, I know that my uh, data is normal distributed and I need to apply parametric. Now my study design, I have only one group. I am giving a drug and checking that that drug is lowering blood glucose compared to normal or not. Hypoglycemic activity I am checking. So for that, I'm comparing that to fixed value. So for that, there is a one test called as one sample t test. I need to have fixed value. I'll be comparing that my data with that fixed value and saying that it is superior to that or inferior to that, or it has effect or it has no effect, like that. So that is study design, and your number of groups will be there. If I have comparison two group, that is, I can say one taste drug and one standard of care. So both are independent to each other. Both are independent to each other. So that is nothing but I need to apply something called as independent t-test. Or on the same individual, first I'm measuring, and then after giving a drug, again I'm measuring, and what is the change? That is nothing but parity test. Okay. If I want to present this in different perspective, in perspective of, I can say, design of experiment, where you have something called as 2 by 3 design, one factor at what levels. So here is also like that. My independent, if I say this, so I have one factor, or I have one treatment at 2 levels. In one, I am talking about this comparison between two groups. So I have a treatment, one factor, 2 level. Which are the level? One, standard of care. Second level, taste drug. So if you have that, you should apply independent test. That is same in same individual. If I have measuring, then you should apply parity test. If I have beyond that, three groups, that is one factor treatment. Now I have three: standard of care, taste one, and taste two. That is called as one-way ANOVA. That's why it is called as one-way ANOVA. One-way ANOVA. Okay. Comparison between three groups, or more than three groups, one way ANOVA. But now I'm checking, I have only one set of individual where before giving a drug, I'm measuring blood glucose level. After giving a drug, after 1 hour of giving drug, I'm measuring. After 6 hours, I'm again measuring. So it become more than 2 times. So I cannot apply parity test. In that, I should apply something called as one-way repeated measure ANOVA. One-way repeated measure ANOVA. Okay. So this is generally in pharmacology research, we go up to this, not beyond this, not beyond this. Okay. So this is whole flow diagram, what you can select depending on that criteria. Four criteria. This is summary table of that. If you are comparing two independent, your type of data is continuous and normal, independent t-test, like that. What I have not explained in this flow diagram is this: if you have two continuous variable, then your research goal is correlation. Then you need to have this Pearson or Spearman, depending on the normally distribution is Pearson, and non-normal distribution Spearman correlation, like that. If you want to have association between that, chi-square test is applied. Predictive analysis, linear regression, and logistic regression. This is same, but the perspective is different of presenting. So because our curriculum say, we say dependent variable at 0 level, 1 level, 2 level, 3 level, like that. That's why I'm presenting in this form. Just now I have already explained what in previous flow diagram also I have tried to explain this levels also. This table is presenting that only. Okay. So this is a few examples I can say. So, for as example, does drug X reduces tumor size compared to placebo or standard of care? This is my, I can say, research question. My design is randomized control trial. So here my independent variable is only one, 2 level. 2 level. One is what? Treatment. 2 level. One is my drug X. Second level is placebo. Okay, my dependent variable is tumor size, which is I am measured in mm square mm. okay, which is continuous type of data. So based on this data, what I have given, first I need to go for normality test and another assumption, that is equal variance. If I'm checking and if it is following normal distribution, then I should go for parametric test for this type of data, because two categories are there, two groups are there. I should go for independent sample